Hello everyone, today we'll learn a really interesting topic which is called thermodynamics. We'll learn all the concepts, laws, and of course applications. So let's get started. First we need to know some basic concepts, and the first concept we need to know about is of course thermodynamics. Well, thermodynamics is the science of the relationship between heat, work, energy, and the properties of matter. But what exactly is heat? Well, heat is a form of energy that is transferred between all these substances or systems because they have a different temperature. And something that we need to know is that energy cannot be created or destroyed. It can only be transformed from one form to another. Another concept that we need to know is about work. Well, work is done when a force acts on a system and it makes it move. It displaces the body into its own direction, and it does not depend only on the initial or final state of the system. Then we have a really interesting concept, which is energy. Well, energy is the capacity for doing work. It makes system potential, which is stored energy, kinetic, as the bird we are watching right now, which is moving. We also have thermal, electrical, chemical, nuclear, or other various forms of energy. Then we have properties of matter, and they divide into physical and chemical properties. Physical properties are the ones that we can measure, such as mass and volume, and chemical properties describe the characteristics, ability of a substance to react with another one. So we'll look at properties such as corrosion or flammability. Here are some concepts, and I want you to pause the video right now and match its concept with a definition and play it when you're done. Alright, are you ready? Here are the answers that I previously told you. In thermodynamics, we need to know what's a system. Well, a system in chemistry is a set of substances and energy, and the universe is everything else that is not part of the system. And the types are open, closed, and isolated system. And I'll explain to you right now how they function. Alright, so an open system is a system in which both mass and energy cross the boundaries of the system. In a closed system, the mass cannot cross the boundaries, but the energy does. And in an isolated system, neither mass or energy can cross the boundaries. Something that we need to remember is that the internal energy, which is the sum of kinetic and potential energy, depends on the state of the system. Now we'll look at some laws of thermodynamics. Okay, so let's start with the zeroth law of thermodynamics, which may sound a little weird, but it actually makes perfect sense. So basically, this law states that if there are two systems in thermodynamic equilibrium, which means they will not share any heat with a third system, the two original systems are in thermal equilibrium with each other. So let's see an example I found in Khan Academy. So let's say we have a freezing pie and then we have a hot knife, and the knife will transfer some heat to the pie until it's reached thermal equilibrium. And then we have another object, which is a glass filled with liquid, and the knife will be in thermal equilibrium with the glass. So basically what will happen is that the object 1, which is the pie, will be in thermal equilibrium with the glass filled with liquid, which is object 3. That's what the law mentions. And a way I like to think about this is about math, the transitive property. So maybe you can remember it like that too. Then we have the first law of thermodynamics. This law is really simple to learn. So basically, this law mentions that energy can't be created or destroyed. It can only be transformed from one form to another with the interaction of heat, work, and internal energy. And we'll see an example right now. So as you can see here, a butterfly, and a butterfly has stored energy, which is the potential energy. And what will happen is, if the butterfly starts moving, it uses kinetic energy, which is the energy of motion. So energy is transformed. Then we have the second law of thermodynamics. So what is it? Basically, this law states that any spontaneous process increases the order or state of entropy of the universe, and the energy will inevitably flow from a higher concentration to a lower concentration. And there's the definition of entropy. So, for example, if we have a hot cup of coffee, it will eventually get cold with time because it will go from high concentration to low concentration. Then we have the third law of thermodynamics, which is the final one. And this law is really interesting because it mentions that we are considering a totally perfect, 100% pure crystalline structure at absolute zero, which means 0 Kelvin, and it will not have entropy. So basically, what's exactly absolute zero? Absolute zero is the lowest possible temperature where nothing can be colder or no heat remains in the substance, and it hasn't been possible yet. So that's it, guys. Thank you very much. I hope you liked it, and all the sources will be linked in the description below.